Hey, what's going on, guys? Mike here. In this video we're going to be generating moves for all the rest of our pieces like knights, bishops, rooks, queens and kings, and they all going to be using almost exactly the same pattern because we're making use of so-called pre-calculated attack tables. And the horror of generating specific special moves like pawn moves and castling moves fortunately behind. So starting from this video it should go a bit faster compared to how it was in the previous video. So without further ado, let's actually start writing some code. So the very first thing to ask here is what kind of piece are we supposed to be picking up depending on side. So let's say side equals to white, and I'm using the ternary operator here. So if case is equals to white, we would be evaluating this expression. So if piece equals to white knight, and the uppercase N stands for white knight, and otherwise if it actually equals to black knight. And the next thing to consider would be to loop over source squares of piece bitboard copy. So just exactly the same stuff we've been doing while generating attacks for our pawns. So we can simply say like while bitboard, and here well, let's actually start with initialize our source square. So source square would be equal get list significant first bit index from the bitboard, which now serves as the copy of either white knight's bitboard or black knight's bitboard, respectively, depending on which side to move we now have. And now the condition to actually break out of this loop one day, we obviously need to populate the less significant first bit of the current bitboard, of the current piece bitboard copy to be exact. So here we can simply say like pop bit, and the bitboard itself, which remember like it is this bitboard I'm referencing is the variable that is getting inside the value of the bitboards array, which is responsible for the entire set of bitboards up to 12 regarding every single piece in particular. So it's getting like bitboard is equal to white pawn, white knight, white bishop, and so on until it reaches like the black king here within this sort of a loop. So every time we're making this copy to make it actually possible to pop the bits out of it within the loop in order to get the list of the relevant source squares. So just to refresh your memory for those of you guys who might not remember that correctly. Okay, and yeah, so just pop bitboard indexed by the source square. So if I now compile and run the source code, it shouldn't get into infinite loop, hopefully. So let's just open the terminal, the current working directory, and by typing make debug, and if it compiles, I want to run the BBC binary executable here. Yeah, hopefully it runs and it doesn't get into infinite loop because we're just popping the bits until they get exhausted within this piece bitboard copy. Okay, so the next thing to consider, we need to initialize piece attacks, and in order to get the set of target squares. Well, let me actually explicitly claim this. So initialize piece attacks in order to get the list, or let's say set of target squares. Okay, and we assign our attacks variable that we've predefined just above there at the very beginning of our move generator. So let me show you this one more time. So here we've defined this attacks variable. It's taken some values if needed, so in case of initializing black like pawn attacks, and here it's time to initialize our knight attacks actually. So it would be equal to I know I'm using this lookup to pre-calculated knight attack tables, so I'm referencing the knight attacks indexed by the source square, the square where which serves the index to index the knight attacks pre-calculated attack table to get the appropriate set of where the knight is about to come from, this sort of a square in particular. So indexed by the source square. And now it's a very important part. We need to bitwise AND this with a current with a site with proper occupancies to make sure that the knight would definitely be capturing opponent's pieces or going just to empty squares, and it won't ever be capturing its own pieces. So depending on the site, so we can say here like if site is equal to white, and again I'm using this ternary operator here, we need simply to say not, this is the bitwise not operator, so not occupancies white. So this means and otherwise not occupancies black. So let me just first actually implement this and then go for explanations like this. So the idea is very simple. Using the bitwise or using this bitwise AND operation with bitwise or that with bitwise not occupancies for white pieces or black pieces, this means that it would reset those bits where where capturing own piece occurs, and it would and the rest of the attack bits would remain the same, just like it has to be basically. So this is a very important part here. So this means like we're not ever to capture white pieces if we're white, and respectively if we're black, we're not ever to capture black pieces. So this bitwise not makes the trick, and obviously don't forget bitwise and the entire attack map with their relevant occupancies. And now we need to loop over target squares. So like here we've been looping over the source squares, so now we need to loop over target squares, and well, target squares available from generated attacks like this. So here I can simply say while attacks, so now exactly the same way we did with our bitboard, which is the copy of the piece bitboard, we're doing the same with the attacks. So the very first thing to consider here, we want to initialize our target square, and the target square, just like in previous case, it would be equal to get a least significant first bit index of our attacks. And now the escape condition, so we also obviously need to escape from this loop one day. So the escape condition would be just like we had here when we were looping over the source squares of a bitboard copy. So we want to pop least significant first bit in current attack set. Yeah, pop least significant first bit in current attack set. And in order to do this, we need simply to say pop bit, and attacks is the bitboard to pop bit from, and the square representing the least significant first bit is actually this target square. So this is kind of it. And the very last thing left here to distinguish is actually to make it different, like captures versus quiet moves. And again, like the reason for this, there is a very important reason behind this, because when we would be implementing the so-called quiescent search, which serves the purpose of getting rid of the horizon effect within the alpha beta search algorithm, we'll need to make only captures, so not all the moves, but making only capture moves. So in order to achieve this goal, we need to make sure that we actually do distinguish between quiet moves and the capture moves. We already did this within the pawns, obviously, but I didn't yet emphasize it. But it's really incredibly important. So the first case would be actually, let's say, capture move, and the second case would be the quiet move. Well, actually, let's put them in different order. So first quiet moves and then captures, like we did before. So here I can simply say if not get bit, and now a little bit of a complicated expression is needed, but it's not really that complicated. So first we need to ask what's the site. So if site is equal to white, and again the ternary operator here, so if site is equal to white, we need to reference the occupancies and the black occupancies. Okay, let me check this. So yeah, so if we're getting the bit on the target square, I didn't yet specify that, but that would have been done just right in the moment. So hold on a sec, or maybe, yeah, I just probably need some extra parentheses here, or oh my god. So okay, so well, okay, let me just get rid of this extra parenthesis. So let me just write the expression first. So in case if the side of move is white, we need to make sure that the target square, we're testing whether there is a bit or not, is available on the occupancies that regards to the black pieces, and otherwise occupancies and white pieces here. Okay, so all this expression we need to enclose within the parentheses like this. And now the second argument for this macro would be the target square like this. And yeah, so now this should work actually. And in this case we can print the capture move. So let me just try to take some pre-coded, oh my god, what have I done? Copy some pre-coded stuff. And so in this case, again, like this is simply the add move function called placeholder. So this would be, let's call this piece capture. Okay, and yeah, it captures the source square and the target square. Yeah, seems like it's just fine. And here we can just let's say piece quiet move, or just piece move. Yeah, probably piece move would be just literally enough. Okay, so it already should work for knights actually. And did I actually restore the tricky position from the previous part? It seems like I did. Okay, so let's try to compile and run the code. Okay, obviously I forgot to put semicolon somewhere or something, so put it here. Okay, let's read what's run here. So generate move 1566 15, excuse me. Oh, I forgot to close the if statement parenthesis. Yeah. Okay, and I don't really like this this layout, to be honest. Yeah, it seems to be correct, but let's make it, let's call it quiet move. Piece capture, piece, just to make the layout a little bit better actually. Okay. Well, I still don't really like it. Well, it would have been better actually. Now I've realized that it would have been better to leave the move specifics on the right side from the move itself. But if I wish I knew that when I started, and I'm not going to be wasting time for this at this moment already. Okay. Okay, so let's actually try to test this, but really, you know, like, okay, yeah, so I will just now pause the video and convert and try to make this specific info being from the right part. So just in order to avoid wasting your time, so I'll just pause the video recording and get back to you just right in a moment. Okay, so let's try this again. Now it should be printed much better. Okay, so we have the mouse on the left and some most specific information on the right. Okay, perfect. Okay, so now let's go and check whether our knight moves are actually generated correctly or not. So we have a knight on e5, so it should go to d7, e7, and g6 with the captures. So knight e5, e5 to c6 capture. Excuse me, hold on a sec. e5 to c6. No, it's not a capture. Something is wrong here. Okay, hold on a sec. It just prints two same moves. What's going wrong there? Hold on a sec. Target square. And this is a bit strange, so okay, let me just figure this out. Oh guys, I'm really sorry. I just obviously this is the conditional as well. I just forgot to put else here, so it now should be working much better. Okay, so let's start again. So e5, and what we got here, so e5 to c6, and he considers this to be a capture, but c6 is here. Okay, what's wrong? Oh, that's because, yeah, I just okay, so this is pawn quiet move, even spelled quite wrong here, and this is the piece capture. Yeah, just the wrong ordering of this print statements. So now it should be working better. So okay, e5 to d7 piece capture. Okay, so e5 captures to d7. Okay, e5 captures to f7. Okay, so this knight captures. e5 to c6 quiet move, yes, which is right. So no square, no piece on c6, which is correct. And e5 goes to g6, captures. Okay, captures on g6, which is correct. And c4, g4, d3 are quiet moves. So c4, c4, and d3 and g4 are empty squares, hence we have these quiet moves. Okay, good. And then we go for a knight with c3, so hopefully not going to be capturing its own pawns, and all the rest of pieces should be quiet moves. So we got this c3 to b5, a4, b1, and d1. Okay, c1, b1, d1, a5, a4 and b5. Yeah, it's not going to c5 or d4 because of this condition here. Bitwise entered with knight attacks. Okay, so well, it seems like actually working correctly. Okay, so let me now try to test this code for black pieces, and it should be also generating moves for black pieces for black knights as well. Okay, so we got a knight on b6, so b6 c8 quiet move. Okay, it is. Then then goes to d5, b6 to d5 capture, and a4 and c4 quiet moves. So goes to a4 and c4 quiet moves. Yeah, this is exactly how it is. And then the f6 knight. Then the f6 knight goes to g8, h7 quiet moves. So g8, h7, h7, g8 quiet moves. Okay. Goes to h5. Okay, captures on d5, captures on e4, and quiet move to h5. So captures on d5 on e4 this knight, then the quiet move on h5, right? Yeah, quiet move on h5, e4, and captures on e4, and g4 quiet move. So also goes here, which is quiet move. Well, okay guys, so this really seems to be working nicely, and now we'll grab this entire code and try to apply it to the rest of our pieces, hopefully. So copy with a minor updates. So here we want to reference the bishop and black bishop in case the side of move is black. Save. Source square remains the same, and now the attacks would go slightly different. While Bitwise engine with occupancies remains the same, we need instead to say get bishop attacks, a lookup function to get the pre-calculated attacks for sliding pieces, including bishop. Well, actually bishop in particular in this case. So get bishop attacks, and using the source square. Source square is square where the bishop is, and also we need to pass the occupancies for both sides. So in this case I need to say occupancies and both, indexed by both. So there are up to 3 occupancy variations, like white occupancies, all white pieces, all black pieces, and both colors. Okay, so this should make a trick for us. So what else? So target square remains the same. Yeah, this logic remains the same. So it actually should already be generating a bishop moves for us. Let's try to see how it works. So let's drop back to white to move. And now the bishop stands, let's say this one, bishop on d2. So let's find the d2. Okay, so get some moves. So it goes to h6, g5, f4, e3, c1, quiet moves. So here they are. So h6, g5, f4, e3, and c1, and nowhere else, so only the quiet moves. So not capturing own pieces, obviously. Okay. And then the e2 bishop captures on a6. Okay, so this bishop captures on a6, which is correct, and then he should go calmly like b5, c4, d3, and then f1 and d1. So let's check that out. So e2, b5, c4, d3, d1, and f1. Okay, just, yeah, f1 and d1. Perfect. Okay, and well, hopefully the same should work for black pieces as well. I will check only these bishops, and all the rest I will just implement them without checking, just in order to avoid wasting your time, guys. You can play around with this on your own side, basically. So I just want to quickly look. Okay, so this bishop like g7, so the g7 bishop goes to h8 to f8 and h6, quiet moves, h8, h6 and f8, f8 and h6, yeah, and then the bishop on a6 goes to c8, so drops back, then probably b7, okay, then b5, c4, d3 goes diagonally until captures on e2, so here, 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 and until captures on e2 and drops there, right? Yeah, captures on e2 and that's it. Yeah, so it seems like working quite pretty nicely. Let me just have a quick look again. Yeah, and it really seems to be working quite pretty nicely. So I will now use this code to do the same for rooks and queens. So let's paste in, and here we go for either white rook or black rook. So you see how easy it is to generate moves when you already have this pre-calculated attack tables. The code is the same for all the pieces. Actually, this is quite almost the same. This is quite pretty handy. So okay, look over the source squares bitboard, and here we want to get the rook attacks. Okay, source square, this all remains the same. Okay, yeah, and here we want to get queen attacks, so white queen or black queen, and get queen attacks. Okay, so hope still compiles and runs. Okay, and the very last thing is the king moves. So it's almost like the knight moves. The only difference is the lookup table. So I will use this knights pattern here, copy, and just to generate the king moves. Okay. So if piece is equal white king or black king, okay, and I want to reference not knight but the king attacks, save. And let me just quickly walk through this one more time to make sure at least it looks like well. So knights and knight attacks, okay, and then bishops and get bishop attacks, source square and occupancies both, rooks and get rook attacks, source square, occupancy both, okay, queens, get queen attacks, source, occupancy both, okay, and kings, okay, king attacks, okay, occupancies, yeah, so this should be just fine. And now the very last test, obviously it's not the way of testing the move generator, but at least the one that we're supposed to be going for in this video, just to save your time guys from watching this, would actually be the following stuff. So I just drop back to white pieces, and I already know that there has to be up to 48 moves within this position if white to move. So if it is so that I will get satisfied, obviously I would just after I stop recording this video, I will check this out even more, but for now it would be literally now just to count the number of moves. So let's go for it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 40. 1, 2, 3, 4, 5, 6, 7, 8. 48 moves. Exactly the exact number we were supposed to have here. So I'm pretty satisfied at this point already, and the next steps to consider would be to actually write some code in order to encode and decode moves as integers, which is quite pretty interesting stuff to consider. We've already been doing a similar thing within our hexadecimal 88 move generator series, but here the move formatting layout is a little bit different because we don't need up to 7 bits to encode from and to square. We need less. I'm not sure how exactly I need to calculate that still, because the maximum number of that we can have here would be the index of 63 for the most significant bit, and the number of bits needed to encode that value is exact number that we need to actually that we'll need to store the from and to squares within the move integer. So this is it guys, basically, and I will go now preparing my encode and decode moves video and materials for that, because I've been testing this with when I was writing the move generator for test comparison, for performance comparison of up to 4 move generators you've seen a couple of videos ago. I wasn't really creating a new move encoding stuff. I've used the previous one, just added one more flag there, and we could have actually go that way, but I really enjoy encoding and decoding moves by hand, so I would love to create another video to cover this topic again. So okay guys, now this is really it from my side. I really appreciate you watching these tutorials and following this, so I wish you all the best with your chess programming. Hope to see you in the next video. Until then, and take care.